Hello everyone. Previously we had discussed on the topic try algorithm, right? So today we'll be discussing on the rolling hash algorithm. So there are only two algorithms left actually in the string based algorithms. So we will be going with the rolling hash algorithm for today, and tomorrow we'll be discussing on the this one, edit distance, also known as the Wagner-Fisher TP algorithm, right? So these are the two algorithms left. So today let's discuss the rolling hash or the polynomial hash algorithm, right? So let's get into the definition part now. So a rolling hash or the polynomial hash is a technique to efficiently compute hash values of the substrings by reusing previous computations, right? So a rolling hash is a technique to efficiently compute hash values of substrings by reusing the previous computations, right? So it's widely used in the string matching algorithms like Robin Karp to speed up pattern searching. So it is used with the Robin Karp algorithm itself, or KMP, Robin Karp, or the Z algorithm, right? So it's widely used in the string matching algorithms like Robin Karp to speed up pattern searching, right? So let's get into the definition part. So first thing here is, so normally for calculating a hash for each substring takes big of n into m time, right? So where n is nothing but the text length and m is nothing but the substring length. So with the rolling hash, we use the previous hash value to calculate the next one in the constant time. So the previous, this one hash value, whatever we have, so that we will be making use of it to calculate the next one in the constant time big of 1, right? So it treats the string like a number in a base system like base p, right? So with the modulus m to avoid the overflow, right? So formula I have just written here, formula for the string. So this itself will be implementing in the form of code or within the algorithm, right? So for the string s, so we will be making use of like this: s of 0, s of 1 to s of n minus 1 is, so this one basically this one h of s equals s of 0 into p to the power of n minus 1, plus we'll be going with s of 1 next into p to the power of n minus 2, plus same goes with this one. Finally it ends at the s of n minus 1 mod m. So we'll be making use of the mod value. Just remember this one, right? So we'll be making use of the mod value. So this is fine. Now mod m. So when sliding over the text, what we will do, we will remove the first character while sliding over the text, meaning, so while we are we'll be passing to the next text, right? So we'll be going with text, or we'll be sliding over the text, next text, or the next character, so on. So while sliding over the text, we remove the first character and add the next character to update the hash efficiently. Just remember this, right? So when sliding over the text, we remove the first character and add the next character to update the hash efficiently, right? So this is the algorithm. Let's try to implement the same thing in the form of code, right? So within the algorithm, so first let's define the base p and the large prime modulus m, right? So now I'll just give here p equals 31. So this is nothing but the base for the characters. Usually this is almost same as the size of the alphabet, right? So extra I have considered a bit, so let me assign this one p to 31, right? So let's consider the modulus value here. I'll just give here 10 to the power of 9 plus 9. So I can just write it on this one in Python, 10 into 9 exponentiation operator. So this one will be plus 9. This is fine. Now this is nothing but the large prime modulus to avoid the overflow. This is fine. Now let's write the function to compute hash of a string, right? So we just have to write the function to compute the hash of a string. So I'll just go with def. So let me go with compute here, this one underscore hash of, let me pass s here. This is fine. Now let me initialize h to 0. This is fine initially. So this one p underscore power, so let me assign this one to the 1. This is also fine. So now let me go with a order of ch hyphen 96 converts this one a to 1, b to 2, this one basically order of the character I'm speaking of, order of ch, this one. So basically it start from 96, right? So 96 converts A to 1, B to 2, C to 3, etc. like that. So I can just write it on this one, and H equals this one has to be H plus, so this one has to be order of CH, this is also fine, hyphen 96, this is also fine. So I haven't written the for loop at all here, that is the reason we are getting error here, this one CH. So just give me a second here. For character and the individual character in the string, yes, right? So this one I had to write, so this one I had not written at all, so that is the reason it was giving me error, it is giving me error here. So right, so this is fine. Now let's do one thing. So this 196 into people whatever I have given here, this one modulo m, modulus value we have to consider, right? So this is fine. Now let me assign p power or p underscore power whatever I have given here. So this one to p power, this one into p, this is fine, modulo m, this is fine, man. Now let's do one thing, let's return h, let's return h here. So this one is h, this is fine. Now let's do one thing, this is it for the algorithm, right? So this is it for the algorithm. Now let's see the what do we call example usage basically, right? So this one will be, let me consider text and the pattern. So text, let me go with some random text here. So I'll just give here ABA, CA, BA, this is fine. Now let me go with the pattern, let me go with pattern ABA, the first three letters. So this is fine. We have to compute the hash for the pattern, right? So I'll just go with the pattern hash here, pattern underscore hash. So this one, let me go with compute hash. Compute hash is the function name, right? So this one, compute hash. So let me pass pattern here. This is fine. Let me pass pattern. So now let's do one thing. Let's pre-compute the prefix hashes for the text. So n equals length of text. This is fine. Again, prefix hash will be, let me go with prefix hash. So this is fine. This one will be 0 into n plus 1. Right. So p power, where is it? So yeah, p power, this one, let me give here. So why this is not showing in the this one suggestions? So this is fine, 1 into, so this one let me give here n plus 1. So let me write the simple if condition here very quick, sorry, simple for loop here very quickly. So for I in range 1 comma n plus 1, so within the for loop let me go with a prefix hash here, prefix hash of I. So this one let me go with prefix hash of the previous number, nothing but the I minus 1 plus order here. So we have given ORD, right? Order of, so let me go with text here. This is also fine. Text of I minus 1, this is also fine. Text of I minus 1 minus 96 or the hyphen 96. So this one into p power, this is fine. So this one I minus 1, this is also fine. Yep, modulo m. This is fine, man. Now let me go with p power, this is fine, of I. Let me assign this one to p power. So this one will be I minus 1 into p modulo m. So this is fine, man. Yep, let's move on with the next step now. we have successfully pre-computed the prefix hashes for the text. Now we have to search the pattern in the text using the rolling hash, right? So now let me consider matches here. Matches, so this one let me assign to the empty array. So let me write the simple for loop here for I in range. So this one has to be n minus length of the pattern that we need to consider plus 1. This is fine. Now within the for loop, what we need to do, so let's get the hash of substring text, nothing but from I to I plus m, right? So let me go with current hash here. Let me assign this one to the prefix hash. We have to consider I plus, so let me pass length of the pattern here. This is fine. Length of the pattern, this is also fine. Now minus prefix hash of I, this is also fine, plus modulo m, this is also fine, modulo m. Yep, this is fine, man. Now let's go with a simple if condition. If current hash, so this is equivalent to the this one pattern hash, this one into p power, so here p underscore power I have considered, right? So this one of I iterated value of the p power, and we have to involve the this one modular value as well, right? Strictly, don't forget, we shouldn't forget this one. This is fine. So within the if condition, let's append I to the matches, right? So this one will be matches dot this is not showing here. Oh, this one matches it has to be matches actually. Now it would show, yeah, matches append of, let me pass I here. This is fine, man. Let me give the print, we make use of print. Let's print something for the interactive purpose. So if let's write here pattern, let's display the pattern found at the particular index or the indices, right? So I'll just go with pattern found at the indices here. This is fine. Pattern found at indices, so let me pass matches here. This is also fine, man. Yep. Now we are done with this part. We are done with this part, right? So let's go with a line by line explanation here. Not line by line, basically let's go with some of the important explanation that is needed, right? So this is fine. Now p equals 31 and m equals 10 to the power of 9 plus 9. So this is nothing but we are choosing the base and modulus for the polynomial hashing, right? So compute hash, this one function whatever we have written, so this converts the string into the hash using polynomial hashing. Again, what it does, this function compute hash, this converts the string into the hash using the polynomial hashing. This is fine. So pattern hash, whatever I have considered here, this one, so equals compute hash, whatever I have given here, compute hash of pattern. So this one will calculate hash of the pattern we want to search actually, right? So this way, right? So prefix of hash, so where I have made use of, so this one has to be into, not 8. So prefix hash equals 0. This one whatever I have made use of, this one here, prefix hash of basically I, so this, not this one, this part, line number 45. So this one stores the hash of the prefix up to index I, we know this one, right? And now we have made use of the current hash as well here in the line number 50. So this one, it extracts the hash of substring using the prefix differences, right? So this is fine. Finally we are comparing with the pattern hash, right? So we are comparing with the pattern hash if equal substring matches the pattern, right? So then we will be appending the matching index to the matches. Then we are appending the matching index to the matches, line number 52. So this is fine. So this is it for the code or the algorithm that we have written, right? So this is it for the algo. In our case, so we have considered A B A C A C A B A, right? So basically, and the pattern is ABA, right? So pattern we have to get the output pattern found at indices, this one, whatever we have written, pattern found at indices within the array, we have to get 0, 4, because at index 0 substring ABA matches the ABA, right? So this one, just give me a second. So at the index 0, see here, this one ABA, it starts from the index 0, right? At the index 0 substring ABA matches the pattern, this one, what do we call, ABA. This is fine. At index 4, this one 0, 1, 2, 3, 4, right? So this one again at the index 4, this one substring ABA again matches ABA. At index 4, substring matches this one, substring ABA matches pattern ABA again. So this ABA and this ABA, right? So this ABA, first ABA, right? So this one ABA and ABA, this at the index 4 and this at the index this one 0, right? So the output that we need to get here is 0, 4, pattern found at the indices 0, 4, right? If we would have extended this one again, if we would have found ABA, so that also we would have added within the array, right? So that also would have added within the array. This is fine. Now we have got the output 0, 4, right? So this is the output that we need to get. I hope we know, right? So we know how we got the output. Now let me run this one. Let me copy the file name here first. So yeah, so let me give here Control J. This is fine. Yep. So let me do one thing. Let me type the Python here, file name .py, right? So see here, we are getting the output pattern found at indices 0, 4. So whatever the algorithm that we have written works absolutely correct, right? So it works absolutely correct. We are getting the desired output. So this is it for the rolling hash algorithm or the polynomial hash algorithm, right? So let me summarize whatever we have learned so far. So until now, so we have finished the rolling hash algorithm. So let me summarize whatever we have learned so far, right? So just give me a second here. Just keep these 3 or 4 things in the mind, man, right? So whatever I say now, so rolling hash converts strings into the numerical hash values for the efficient substring comparison. We know this one from the definition part. So it allows updating hashes in big of one time when sliding over text. We know this. Second one, it allows updating hashes in big of one time when sliding over text, right? So this is second one. The third one is it is widely used in the string matching algorithm, also known as a Robin-Cobb algorithm, and detecting the duplicates. It's widely used in string matching algorithm, nothing but the Robin-Cobb, and for detecting the duplicates. The final one, so in our example, whatever the example that we considered, ABA was found at the 0 and 4th indices, right? So that is the reason we have got the output here 0, 4, right? So yep, the first 3 things that I've said, 3 points, just keep that in mind, right? So this is it for the rolling hash algorithm. So tomorrow it's gonna be the this one, the last algorithm within the string based algorithms playlist, right? So we'll be discussing on this one topic, edit distance algorithm, also known as the this one, Wagner-Fisher DP algo, right? So yep, for now this is it. Thanks for watching, guys.